Okay, this next video is going to go over part 6 and 7. I'm actually going to start with part 7 because this will go real fast. So remember, we did this question together in class, and the points that you can use have to still make this a congruent triangle. And it has to be congruent in this order. And so if I look at point B, that's the middle of this. So K and B are my corresponding angles. And so if B is a right angle, K has to be a right angle. So this is going to have to either go this way or this way. And then it still has to be congruent. So if this is going 1, 2, 3, 4, 5, 6 boxes, this can only go the same 6 boxes. So these are the only 2 points out of the whole coordinate that would work for point L to make that a congruent triangle. And it's really just because this order has to be the same. If it didn't have this congruency statement and it just wanted any congruent triangle, there'd be other options. But because it's congruent this way, it has to be like this. When I'm making my congruent triangles here, remember you can always use patty paper. You could trace this on patty paper and then make this so you could find the point. Or you can use your slopes. So the point that I don't have is point Z. So that's the same as point K. So one option is if I'm looking at this LK line that goes this way, I know my XZ line has to go this way, and it has to be the same. So if this slope is going 1, 2, 3, 4, 5, 1, 2, 3, 4, 5, it went down 5 and over 5. So that means this would have to go down 5 and over 5 in order to make it congruent. Or if you notice that this is just a mirror image, a reflection over the y-axis, if this is going over 2 spaces this way, Z would have to go over 2 spaces this way. Either way, there's multiple ways to get the Z, and a lot of you were using patty paper the other day, which is perfectly fine. But on your quiz and then on your test and tests in the future, you're going to have to know how to make these figures. So back up to the proofs. Starting with proof 6a. These all have a lot of steps, just so you know. So starting with 6a, it's given that CB is parallel to AD, and M is the midpoint of AB. I'm going to zoom this out a little bit. That's my proof. So starting with step 1, I always start with the given. So I'm going to start with the fact that M is the midpoint of AB. Oops, that's a 1. Which is given to me. So I know that if M is the midpoint of AB, that's congruent to that. So that's what I'm going to write down. AM is congruent to MB, and I knew that because that's the definition of a midpoint. It creates congruent segments. Then I know that this is congruent to this. Angle 1 is congruent to angle 2 because vertical angles are congruent. So far I have these sides are congruent, these angles are congruent. So because of I know that I'm going to need to find out congruent triangles at some point. I need either another angle or I need another side. But if I go back to my given, I was still given this information. So I'm going to write that down. CB is parallel to AD. And I need to think about, why was I given that information? Why does it matter that this line is parallel to this part? Well, if I use this as a transversal, that would make alternate interior angles here. And I know that alternate interior angles are congruent. So angle A is congruent to angle B because alternate interior angles are congruent. Oop, you cannot even see. I am so sorry. Now you can see the picture, the struggle, the struggle, the struggle. Okay. So now I can prove that my two triangles are congruent. So triangle MBC is congruent to triangle MAD. And I can use angle side angle. So my whole purpose is to prove that M is the midpoint of CD. So because I know a midpoint means that that's in the middle, I need to say that these are congruent to each other. I can say that using CPCTC. So CM has to be congruent to MD because of CPCTC. So if these two are congruent, that means that M has to be the midpoint. Because that's the definition of a midpoint. My congruent segments. And this is what I was trying to prove. So I am finito. Moving on to proof B. Trying to let you see more. Okay, proof B. I'm going to draw a picture. So I have A, B, C, BD bisects it. So that means those parts are congruent. ABD is 9x plus 1. And CBD is 7x plus 1. I'm trying to prove that this part equals 28 degrees. So here goes nothing. I can start with BD bisects angle ABC. That's my given. Next, because it's bisecting it, I know that angle ABD is congruent to angle DBC, because that's the definition of a bisector. Then I know that angle ABD equals 9x plus 1, and angle DBC equals 7x plus 1, and that was given to me. So we don't really need this right now. Okay. So then from there, these are congruent. I know what they equal, so I can substitute them in. Now I need to solve for x. So it's going to take a few steps. And you have to do each step individually. So first I distributed. Now I need to move these over here and these over here. I'm going to combine that step because it's the same. It's the subtraction, which is actually addition, or the addition property. And then I need to divide, so I get x equals 3. So that's the multiplication property. And remember, I'm trying to prove what ABD equals. So angle ABD equals, that was the 9x plus 1 part. So 9 times 3 plus 1. So that's substitution. And then when I solve angle ABD, that's 27 plus 1 is 28. So that's simplifying. Whew. And I'm done. I know, it's a lot. Get over it. Love you. Okay, so I did that and that. I thought I had some more paper. I'll use the bottom of this paper for letter C. Let me get situated here. Excuse me. My apologies to you. Okay, here is... Wow, how did that get so close again? Okay, here's letter C. So I have that given angle A and C are right angles. They don't look like it, but they are. And AB is congruent to BC. So I have angle A and angle C are right angles. That was given to me. Then I need to say that those are right triangles. I know they're right angles. I need to say that they're right triangles. A, B, D, and triangle C, B, D are right triangles. That's not a 3, it's a 2. That's because the definition of right triangles, we did that today, which when you're watching this, that was yesterday. Then, now I know these are right triangles, I know these are congruent. I can say that that part's congruent. Reflects it. And now I have, I can say that they're congruent for the HL. So triangle ABD is congruent to triangle CBD. And that's HL. And if they're congruent, then that means that angle ADB is congruent to angle CDB, because congruent parts of congruent triangles are congruent. So if my congruent parts are congruent, if these two angles are congruent, that means this has to be the bisector, because that's the definition of a bisector. So then you can write BD bisects angle ADC, which is the proof we're trying to prove. And the reason is definition of angle bisector. Whew. And now that one's done. So those are your 3 proofs. It's a lot. It's okay. It's okay if you didn't get all the steps exactly perfectly, but I hope that you at least understand where I got them.